Hello and welcome back to Cat Science and Maths. Now we are the channel that will take you from the beginning of your GCSE Maths and Science course right to the very end with short, easily digestible videos just like this one. This is Chemistry Lesson 2 and it's all about electronic configuration. So let's get started. In the last video we looked at atomic structure and what the term atomic number, which was this bottom one down here, and mass number, which was the one at the top, we looked at what they meant. And we said that from those numbers we can calculate the number of protons, electrons and neutrons. Now, just as a very quick recap, we said that the atomic number down here, which is the atomic number 11 for sodium, tells us the number of protons. So we have 11 protons and they will be in the nucleus. We said that the number of protons is always the same as the number of electrons. So we will have 11 electrons outside the nucleus. And we said to calculate the number of neutrons, we look at the difference between the mass number and the atomic number. So in this case, we will have 23 minus 11, which gives us 12 neutrons, which are in the center of the atom. But what we didn't look at is the electrons themselves and how they are actually arranged around an atom. In the video yesterday, I think I showed you pictures of atoms that just looked all kind of random, and that's not really how it works. So here I have my sodium atom, and the nucleus in the middle, I've put a little plus 11 in that to represent the fact that we have 11 protons in the middle of that sodium atom. Now that means, obviously we know we have 11 electrons, but where do those electrons go? Well, you can see around the atom that I have these what look like racetracks. Okay, your teacher may have referred to them as orbitals or even electron shells. Now, electrons can only live on these shells. I can't draw them randomly wherever I want. They have to be on these circles. And you'll always have those circles drawn for you on your exam. You'll just have to mark the electrons on them. So I have to put 11 electrons on these circles. How do I know where they go? Well, the simple rule is I have to start with the first circle, the one closest to the nucleus, before I can move out. And I can put a maximum of 2 electrons on that circle. Now you'll notice the first one, and this is a good habit to get into, I've put at the very top of the circle, and the second one I've put at the very bottom. We'll talk about more why in a second. But now that first shell is full, it can only hold 2 electrons. I can't hold any more electrons than 2, so I've got 9 left to give. And every single other shell after this can now hold 8 electrons. But watch how I put them on. When I put my electrons on the second shell, I'm going to put one at the top and one at the bottom like I did before. And then I'm going to put one on the left and one on the right. And I'm equally spacing them out. And once I've done that, top, bottom, left, right, I'm going to repeat until I get to my 8. Top, bottom, left, right. So I have 2 on the first shell, 8 on the second shell, which gives me in total 10 electrons. And I've got one more to place. And I'm going to place that here. Now, if I was asked to write down the electronic configuration or the electronic structure for sodium, all I have to do is look at the number of electrons on each shell and simply write those numbers down with a comma in between. So, for example, for sodium, I have 2 on the first shell, I have 8 on the second shell, I have 1 on the third shell. So my electronic configuration, my electronic structure for sodium is simply 281. Now, why did I ask you to put them on north, top, bottom, left and right? Why did I ask you to do that? Well, electrons don't group themselves randomly on these orbitals. Electrons are negative charges and they like to repel each other and be as far away from each other as possible. And the best way they can all be as far away from each other as possible is if we have them north, south, east and west. Now you might be asking, why then do we draw these in pairs and are they not spread out a little bit more? Well, maybe when you get to A-level or university, that one can be answered for you. Let's do another example. We've got calcium. So we look at calcium. Protons, we have 20 because my atomic number is 20. Therefore, we must have 20 electrons. And neutrons is the top number minus the bottom number, 40 minus 20. We've got 20 neutrons. So where do those 20 electrons go? Whoops. Well, same as last time. On the first shell, I can only put 2, top and bottom. On the second, which leaves me with 18. On the second shell, I'm going to have 8. It'll take me a while to draw this one. Might want to hit the fast forward button. So there's my 8, which gives me 10 in total. And you know what, I'm going to cheat a little bit here and just put them in pairs because we know how they're going to end up. So I now have 2, 8, 8. 2 plus 8 is 10, plus 8 is 18. And I've got my final 2 to go. And if I was to write down the electronic configuration for this, I'm hoping that you'd all be able to say, well, I've got 2 on the first shell, followed by 8, followed by 8, followed by 2. So my electronic configuration for calcium is 2882. Fluorine is much more simple. There's only 2 electron shells. We have 9 electrons, which we can see down at the bottom. And I'm hoping at this point, without even drawing the atom, you might be able to think of the electronic configuration for yourself without putting them on the atom. You might be thinking that, well, fluorine must have 2 in the first shell, which leaves it with 7 to go in the second shell. So its electronic configuration must be 2, 7. And if you've got that far, then well done. There's only one more thing for us to chat about. We'll skip drawing them on fluorine because I think the point's been made. I want us to look at helium very quickly. Actually, before I do go on to my final point. Helium only has 2 electrons, as we can see from the atomic number, which means it only has 1 shell. There's only one other element with 1 shell, and I hope that you're all thinking, oh, that's hydrogen. And hydrogen only has 1 electron. And that's fine. Why have I mentioned helium? Well, we'll see in a second. Here is the periodic table, and this is why electronic configuration is so important. Let's have a look at sodium over here. Now, we said sodium had an electronic configuration of 281. Now, it's in group 1. Another one of the elements we looked at was calcium, which was here. And we said that calcium had an electronic configuration of 2882. And it's in group 2. Another one we looked at was fluorine over here, and we said that had an electronic configuration of 287, and that's in group 7. And I'm hoping that as I've said that to you, you've kind of twigged that if you're in group 1, look at that, we have 1 electron in our outer shell. If we're in group 2, we have 2 electrons in the outer shell. And if we're in group 7, we have 7 electrons in the outer shell. Now, for all the elements you will encounter at GCSE, this rule of 2, 8, 8 up until you fill your final shell will always leave you with the same number of electrons in your outer shell as your group number. Very, very, very important. So any of these elements in group 1 here, any of them, will all have 1 electron in their outer shell. Any of these elements here in group 3 that you will encounter will all have 3 electrons in that outer shell. Any of them in group 7 will have 7 electrons in their outer shell. Now, that is why elements are placed in certain groups in the periodic table, because the way they react chemically is determined by the number of electrons in their outer shell. So the reason they are in the same group, because they react in the same way, is the fact they have this same number of electrons in their outer shell. But the periodic table is another lesson. The one exception that I brought up was helium. Helium is here, and that's in group 8. So you might be thinking, well, all the atoms in group 8 should have 8 electrons in their outer shell. And if we start from neon and go downwards, they certainly do. Okay, they would all follow 28, 288, 2888. But helium obviously just has 2. So why do we put it in group 8? Well, because helium only has 1 electron shell, that means it's full. Okay. Now, if it had 2 electron shells, to be full, it would have to be 2, 8. Okay. If it had 3 shells, to be full, it would have to be 2, 8, 8. Okay. But it hasn't. It's only got 1 shell. So to be full, it just has the electronic configuration of 2. And when we look at the noble gases, group 8, what gives them their chemical properties? The fact that their outer shell is full and we can't fit any more electrons on it. So that's why helium fits in with group 8. Now, on the next lesson, I'm going to talk to you about isotopes and what isotopes are all about. But hopefully now you can write down the electronic configuration for any electron, for any element even. And you'll also be able to link the group that something is in with its electron configuration. Good luck. Now, if you found this video useful, please consider hitting that subscribe button, and don't forget, if you click on the playlist button, you'll be able to see videos just like this for biology, chemistry, physics and maths. And don't forget that patrons of the channel will not only have a say in what videos are made next, but you'll also have the opportunity to send me questions about your GCSE studies through the Patreon app.